The consensus seemed to be, at least in second period, that some of you wanted feedback on what you're doing. And I don't want to use a ton of class time, so I thought maybe I would do a couple of these limit sketching problems for you. When I look at these, the first two, I don't know, pieces of information that pop out at me are f of 2 equals 3 and f of negative 3 equals 0. So those are just ordered pairs, negative 3, 0, and 2, 3. I'll graph those first, maybe even put 2, 3 on here. Okay. The top two limits, the limit as x approaches infinity of f does not exist, and it says negative infinity. So I'm thinking down here, the graph is going to dive off towards the bottom. The limit as x approaches negative infinity of f is 2. That's left-hand end behavior. So I'm thinking horizontal asymptote. Now I don't know if this graph is going to come down towards 2 or come up towards 2 yet, but I think those two parts are good. The limit as x approaches 2 from both sides of f is 5. Uh-oh, but I already have this 0.23, so that means f must have a hole at 2. And I don't know whether f goes down or up from that hole, that removable discontinuity. So I'll just leave a couple of tails. What are we looking at now? The limit as x approaches 0 on the right-hand side does not exist, goes towards positive infinity. So 0 on the right-hand side goes towards positive infinity. I'm not going to connect anything, don't know where anything's going. The limit as x approaches 0 on the left-hand side of f is going to be negative 2. I'll leave that an open circle for now and leave a tail on there. I don't know if I can close that or if it matters. I already covered f of negative 3 is 0. The limit as x approaches negative 3 on the left. Okay, negative 3 on the left of f is 0. Well, that seems pretty easy. The limit as x approaches negative 3 on the right of f is 4. Oh, that's why it's hard. 1, 2, 3, 4. And a little tail off to the right. And the limit as x approaches 5 of f does not exist. I don't really like that. I assume we meant x approaches 5 on the right-hand side of f is infinity. And the limit as x approaches 5 on the left-hand side of f is negative infinity. I think it's a little crazy to say that the two-sided limits are equal, even if they both don't exist. Okay, so 2, 3, 4, 5. And we want this to go toward, positive infinity. Positive infinity on both sides. Okay, so now I suppose the hard part is connecting the dots. So starting on the left, this graph approaches 2, and then what's the next thing? It looks like I need to connect it down here to 3. Then I left myself a tail for earlier. I'll just connect down there. I have a problem here. To the right of 0, f will need to approach positive infinity, and I'm sort of off the graph, so that's not a problem. I'll just make that part dip down. If your graph went up here, that would be fine as well. I just think it's hard to show growth towards positive infinity. I already took care of this ordered pair 2, 3. So I need to just connect up here. And then the last two bits. I suppose something like that will work. Oh, it's pretty ugly. Let's see. Let's make sure everything's correct. The limit as x approaches infinity of f does not exist, goes towards negative infinity. That's true. As x goes towards negative infinity, f approaches 2. That appears to be true. The limit as x approaches 2 on both sides of f is 5. So here's 2. The y value up here is 5. That's a good limit on both sides. F of 2 is 3. The graph of f contains the ordered pair 2, 3. The limit as x approaches 0 on the right-hand side of f does not exist. Trends towards positive infinity. That looks good. The limit as x approaches 0 on the left-hand side of f is negative 2. X approaches 0 on the left-hand side. F goes to negative 2. F of negative 3 is 0. F of negative 3 is 0. X approaches negative 3 on the left of f, gives us 0. Looks good. X approaches negative 3 on the right of f, gives us 4. That looks 1, 2, 3. Ooh, that doesn't seem to be quite high enough. Maybe we'll even say, hey, negative 2, 4 is where this hole is. That way no one can mess that up. Maybe we'll do that here. 2, 5 is the ordered pair for that hole. Okay. Does that look right? Negative 3 from the left of f approaches 4. Looks good. And the limit as x approaches 5 on f, I guess of both sides, go to positive infinity, infinity, infinity. Looks good.